Linear inequalities. This time we do linear inequalities with word problems. And then if I want to make the title even longer and goofy little tricky questions. Like this one. What do you do with this? Well, you did questions like this before. This looks like a fishing thing, doesn't it? We'll fish it. This is like our equal sign, and we'll solve it. So let's do it. Hey, don't be freak out about something different. And that's the, I guess, underlying theme to all this, is some questions will look a little bit different, but don't freak out. You know the basics of algebra, getting the letter by itself. Just because the numbers look a little bit weird and have decimals and fractions in them, don't freak out. Just go with what you know. And what you know is, you know how to solve for equations and inequalities. So there's your first inequality. You've got this brackets. We're going to fish this side. 5 times m is 5m. 5 times positive 11 is positive 55. Greater than equal to 30. The m is being bugged by the 5, which is multiplying it. It's also being bugged by the 55. So we can get rid of this 55 by subtracting 55. We do this first, remember, because SAMDEB, reverse BEDMAS. Get rid of the adding subtracting thing first. Do the same to the other side. We're gone. You're left with 5m greater than equal to 30 minus 55. You have 30, then you're down 55. You're down 15. Now remember, one of the big things from the last lesson is you switch the sign whenever you're multiplying or dividing the variable by a negative number. Yeah, sorry about that. I just kind of broke it up. But yeah, when you're multiplying and dividing the side by a negative number, then you need to switch this sign. Do we need to switch the sign here? No, we don't. Because to get rid of this 5, which is multiplying the m, we need to divide by 5. Positive 5. Divide by 5. Positive 5. We're dividing by a positive number, so nothing needs to get changed. The 5's cancel out. M is greater than equal to negative 15 divided by 5. Signs are different. Negative 3. And if you were to graph that, we throw the negative 3 there. M is greater than or equal to. What that means, this means at solid dot, it could be negative 3. And it's greater, so that means you go to the right. Or left, sorry. Left, right. Wrong way. The other way. Bigger. This is the bigger direction. Yikes. This is the bigger direction. Come on, undo. This is the bigger direction. Oh god, here. I don't want to have to do this video over again. You know how many times I had to do this video? Over and over and over again? I had to this is like take 3 on it. You know what? There's the line. There we go. It's like that. Greater. So greater is in that direction. Done. You can do the check. You can any 3 numbers or any few numbers that you want to do that are greater than negative 3, like negative 2, like 0, like 1, like a million, like 100. Sub those numbers individually into there for m. Do this all, and you should get the inequality that works. I'm not going to do it for you. It's going to take too long, but you should be able to do that. How about this? 6 is less than v divided by negative 4 plus 19. So this side is less than that. What is the deal here? Where there's the v, a rarely used variable letter, it's being divided by negative 4 and added by 19. Who should we get rid of first? Remember, you get rid of the adding subtracting thing first when two things are bugging the letter. Get rid of the 19 by subtracting 19. Same to this side. 6 minus 19, you have 6, you lose 19, you're down 13. Leave that there. This goes away, and you're left with v divided by negative 4. How do we get rid of this negative 4? Well, we see that negative 4 is dividing the v. So to get rid of it, we need to do the opposite of dividing, which is multiplying by negative 4. So we multiply this side by negative 4. We multiply the numerator, the top number, and multiply this side by negative 4. Whoa! The alarm went off. We're multiplying by a negative number. So that means, what does that mean? That means that this inequality sign needs to switch from that direction to that direction because we're multiplying by a negative number. These cancel out. You're left with v. Negative 4 times negative 13. They're multiplying each other, right? Signs are the same. Positive 52. So on quick graph, you should get that 52 is greater than v. So 52 is going to be bigger than v. It can't be equal to it. So hollow dot this way. Done. Okay. Moving on. This is easy, right? Oh, and now you're going to start crying because there's fractions, right? And you're going to go run, hide, and cry, complain to your mom or something. Oh my God, this teacher's giving me fraction questions. Why? What's the matter with fractions? You know how to do them. Chapter 2, you did a whole bunch of them. It's the same deal here. 1/3 less than or equal to x minus 1/4. The x is being bugged by the 1/4. How do we get rid of it? Add 1/4 to this side. Add 1/4 to that side. They're numbers too, okay? Just do it. On this side, then you're left with x. On this side, 1/3 plus 1/4. Well, what is 1/3 plus 1/4? Let's do a little side work over here. 1/3 plus 1/4. Don't say 2/7, please don't. Wash that out of your brain if you think that's what you have to do. Common denominator, if the denominators are different, make them 12. What do we do to 3 to make it 12? Times by 4. Do the same to the top. 4 times 1 is 4. Doesn't this feel familiar and kind of feel good? But how do we get 4 to make it 12? Times it by 3. Do the same to the top. Good times, good old times. That gives you 3. Add the top, leave the bottom. 7/12 is your answer. So that 7/12 will go there. Now you're probably thinking, yeah, okay, I remember that, but how do I graph it? What, you've never seen a fraction before? Hopefully you know that 7/12 is greater than 0 but less than 1. 7/12. Actually, you don't even have to even know that for this. So we're saying that 7/12 is less than or equal to x. So that means it could be equal to it. Or you can rewrite it the other way. X is greater than or equal to 7/12. Okay, so the number x is greater. That means it's on this side. There you go. Now to check it, if you're going to check it, which I'm not going to do to save time, is pick any numbers, fraction or whole numbers, that are greater than 7/12, like 1, like 2, like 9, like 99, like whatever, and sub them into here, and you check it, and if it works out to be true, then you're right. How about this one here? K plus 8/5 is less than negative 3/4. K is being bugged by the 8/5. Subtract 8/5. Same to the other side. The 8/5 are gone. You're left with K. And negative 3/4 minus 8/5. Do it on the side. Negative 3/4 minus 8/5. Or, if that's not what you see there, then you could think it's negative 3/4 plus negative 8/5. Double sign becomes a negative. Either way, they mean the same thing. Okay, 4 and 5, common denominator you need, because you're subtracting, 20. How do we turn 4 into 20? Times by 5. Do the same to the top. Negative 3 times 5 is negative 15. Leave the minus sign there, and treat this as a positive 8. How do we turn 5 into 20? Times by 4. Do the same to the top. 8 times 4, 32. So you're down 15, then you're down 32. That means you're down 47 over 20. That's improper. We should turn it to mixed. Do you remember how to do this? You see how many times the bottom number goes into the top. It's twice, with 7 left over 20. Don't forget the negative sign. So the answer is K is less than negative 2 7/20. On a graph, there's negative 2 7/20. We're saying that the numbers, the values have to be less than that, but not equal to it. So it's a hollow dot going that way. Less than. Word problems. I advertise word problems. You're thinking, where are these word problems? Here they are. So, little refresher. Twice a number increased by 4 is at least 10 more than a number. What's the number that we're talking about here? So, the important thing with these questions is, like the word problems I showed you before, the is or equal to, that meant your equal sign. But this now is saying is at least. Well, what does that mean, is at least? That means the one side, which they're talking about here, is equal to, or is at least, that means it's bigger than the other side. So we have to translate first. We translate, what does this mean? Twice a number increased by 4. Twice a number means 2 times a number. So 2 times, but you're not going to put the lame little x there, a number. Let's just call it n for a number. We could. Or I'll just be boring and just call it x for that number. Twice some number increased, that means plus, by 4. That means a 4. And then let's leave some space here to figure what sign we're going to put here later. 10 more than a number. That means on this side it's 10. More than means plus. The number is x that we're calling it. It's the same number. Twice the number increased by 4 is at least 10 more than that same number, x. Is at least. So is, that means they could be equal. At least, so they're saying this is at least 10 more than that side. So it means this side is greater. So that means that's the sign we're going to use. All right. And from here, it's just doing the regular stuff we've been doing all along. Variable on this side, variable on that side. Let's solve for x. What is x? Pick on the small x, because we want to get rid of the variables that are on either side of the equal sign. Get rid of that x. Get rid of an x there. These x's are gone. 2 minus x is just x, or 1x, plus 4, greater than or equal to 10. Now this is easy. Minus 4, x is greater than or equal to 6. I'm not going to graph these anymore. I showed it many times already, but that's what it is. X greater than or equal to 6. Hollow dot, solid dot. What do you got to do? Solid dot. That's all I'm going to say. Let's move on. And you would check it too with any numbers greater than 6, like 7, 8, 9, 10, 25, 97, whatever. Okay, now let's get to some juicier word problems like this. A widget factory makes and sells widgets for $4.20 per widget. Now before you start making a little weird face saying, what's a widget? Use your imagination. Alright, whatever you want it to be is a widget. So this widget factory makes and sells these things, and like most businesses, they want to make money. That's why they're selling these things. They want to make money. They make their money by selling these widgets at $4.20 per widget. The thing is, we don't know how many widgets they're going to sell. Of course, there's always in a business costs that go along with a business. So $1.20 is what it costs to make a widget, for the supplies for the widget, to buy all the stuff and whatever, right? To make the widgets themselves. Plus $3,600 that just goes into other costs. Heating the building, renting the building, paying your workers, all that kind of stuff. Okay, so what we're asking is, like any business will ask, what's the least number of widgets needed to be sold to make a profit? Make a profit. Make a profit. Profit means that your sales, or the money that you bring in, is going to be greater than your costs. Right? Can't be equal, because if it's equal, your sales and your costs are equal, then you break even, you have nothing. There's no profit. I want money. They want money. The widget people want money. So sales greater than costs. What are our sales? Our sales comes from the $4.20 per widget. How do you write that? We don't know how many widgets we're selling, so that's our variable, widgets. $4.20 per widget. So that means if we have one widget 1 times 4.20, $4.20. 2 widgets, 2 times $4.20 gives you $8.40. So the equation we're going to write here, or inequality we're going to write, is going to say $4.20 times the number of widgets, which we don't know. Let's call it W for widgets. So $4.20 per widget, which means times widgets. Don't do the lame little time sign there, just come on. That means times. So that's our sales, and that has to be greater than, of course, greater than the costs. What are the costs? It costs $1.20 per widget. So each widget, I don't need the dollar sign. Let's do $1.20 for each widget sold. So to figure out how much the costs are going to be, we will times that by the number of widgets. And 3,600 plus 3,600. That's just reading the word problem, which you got to do. I know some of you don't like to read. Nick is math. Why do we got to read? You got to read because this is real life math. This is where you apply this math into real life. Okay? If you're going to business, you use this kind of stuff all the time. All right, so there's our inequality. And now it's just the math part. I guess the somewhat hard part was translating all this into here. It might take some time for you to figure that out, but hopefully I explained it well enough the first time. You got a variable here and a variable there. Pick which one should I get rid of? Let's pick on the small one. Get rid of 120 widgets. Do the same to this side. That's gone. You're left with that minus that is 3W and 3,600. We divide by 3, the 3's cancel out, W is greater than 12. So that means we need to sell, 1,200 is what you should get when you divide those two. Anyways, you need to sell at least 1,200 widgets per month to make money. Is that a lot? Is that a little bit? It depends on what you imagined a widget to be. Now, neat thing when you if you were going to graph this, we're saying that there's 1,200. Well, we have the values have to be greater than 1,200. Now, on a number line, you could put 1,200 right here. But can we just draw like a solid line through? No, you can't, because you can't buy like half a widget or a third of a widget or 0.57 of a widget. So here's a case where we have discrete numbers. We're going up by actual whole numbers, and I'll talk about this later. So the graph actually would look like this. You can have 1,200, you could have 1,201, 1,202, just and going on forever that way. And since it can't be those, it can't be, you would just say that anything greater than that but will be the acceptable number of widgets sold. I'm not going to fill in this because if I filled in that, then I'm saying that I could sell 1,200.2 widgets if I put it right there, the line right there. That's not true. I can only sell whole number of widgets. So instead of drawing a line, I just shade in the amounts, the numbers, the whole numbers that are past or greater than 1,200. Okay. Let's move on to the next one. Super slide or Euro slide. I don't know. Yeah. Anyway, this is a super slide. Take a look. There's the kid having fun going down a slide, and the little mat there, and they zip and zoom down. The super slide ride costs $1.25 to rent the mat and 75 cents per ride. So the mat, you gotta just pay $1.25, and then for each ride you get up, you gotta pay 75 cents. Now Rico really loves his rides. Okay, he really loves his super slide rides. He's got $10.25 that are just burning a hole in his pocket. They're really bugging him, and he wants to spend all that money on this super slide ride. How many rides can he go on if he spends the maximum 1025? Okay, so we have to turn this into an inequality. His costs compared to what he has. His costs are $1.25 to rent the mat, flat fee, $1.25 to rent the mat, and per ride is 75 cents. So that means 0.75 multiplied by the number of rides he goes on. One ride, 75 cents. Two rides is 2 times that, $1.50, and it goes on and on and on. So we're going to put a variable here. Number of rides is what we're looking for. So R for rides, yeah, sure, why not? And then on the other side we have his 1025. Now, which side is greater, which side is less than? What's the deal here? Okay, since 1025 is the max you can spend, this is the maximum amount. That means this side has to be greater, maximum. Now, could it be equal to 1025? Could he spend every penny? Yes, he doesn't mind. He will spend every penny of his 1025 to be able to go on the ride. So you're going to say that this side has to be less than or equal to 1025 to figure out how many rides he can go on. Okay, so what? There's decimals here. Big deal. It's the same story. There's the variable. There's only one variable on this side, so we just got to get the variable by itself. It's being multiplied by this and being added by that. Let's get rid of this by subtracting, because Sam Deb tells us that. Minus 125. Gone. 0.75 rides. Less than, equal to. That minus that is 9. 0.75 times R, divide by 0.75. Divide by 0.75. Just because there's decimals, you don't freak out. That cancels out. You're left with R less than or equal to 9 divided by 0.75 is, on a calculator, if you want to, go ahead, do it, 12. So R, the maximum number of rides you can go on is 12. So if you're going to go on a ride, if you're going to graph this, actually, again, rides are like whole number things. You can't go on half of a ride or 0.67 of a ride. So if you're going to do your graph, what you would do is, you know that 12 is the max. So you put 12 here, and you can go, and anything less than that you can go on. So nothing's going to go ahead, so no need to put the 12 in the middle. 12, 11, 10, 9, 8, blah, 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 blah. These are all potential times you can go on a ride. So we do not draw the line, we just shade them in as dots. Because again, you can't go on half of a ride, so you can't draw a line. Okay? The other ones you could. Up here, it could be 52, 51.5, 50, so that's why we drew the line. Every single number would work there. Not here. Not here because you can't go on, you can't buy fractions of widgets, and you can't go on fractions of rides. Only on whole numbers. And you can check it. Okay, last question. Phone plan A, phone plan B. Look at phone plan A. Its monthly fees are $25 plus 10 cents a minute. Phone plan B monthly plan is $10 plus 15 cents a minute. When you first look at this, you're thinking, oh, phone plan B is definitely more cheaper. To a point. For the person, it might be who doesn't call that much. But phone plan A might work out because it's cheaper per minute to call. So if you talk a lot, maybe this will be cheaper for you. You talk a lot on your phone. If you don't talk a lot on your phone, then this might be better. So the question is, at what point is phone plan A more expensive than phone plan B? Okay, or around. At what point would phone plan A be better? I should rewrite this. After how many minutes will phone plan A be cheaper? Than phone plan B. Okay, so first let's write the inequalities out. What is phone plan A? $25 plus 10 cents a minute. So $25 plus 10 cents a minute. So we're going to multiply. When you have the per minute, that means you're going to multiply these two things together. Call it M for minute. Phone plan B is $10 plus 15 cents a minute. So we want to see after how many minutes will plan A be cheaper, less than plan B. Let's do this. We have our variables, one on that side, one on that side. Let's get rid of 101. Which one should we get rid of? This one or that one? Pick on the small one. Get rid of this guy by subtracting. Subtract on this side as well. That's gone. You're left with 25. Less than 10, and then 15 cents minus 10 cents is 5 cents, or $0.05. M, whoops, that's plus, right? So the M is being bugged by that, which is multiplying it, and that, which is doing what? It's adding, I guess, or there's an imaginary plus sign out here, so we subtract 10 to get rid of it, subtract 10 to get rid of it, you're left with 15. Less than, these are gone, 0.05 minutes. 0.05 times minutes, sorry. How do you get rid of this? It's multiplying, divide by 0.05, divide by 0.05, 0.05s are gone, you're left with M being 15, divided by 0.05. Which, trust me, use a calculator. Well, here, I'll do it for you. 15 divided by 0.05. 15 divided by 0.05 is 300. 300 minutes. So what this means is plan A will be better only if you talk for more than 300 minutes a month. Anything less than that, it's not going to be more, better. Okay, so plan A is for talkers. You talk for more than 300 minutes, this is the plan for you. And we just figured it out. We could graph it. Now, quick question for you. Would this be, if you were going to graph this, which I'm not going to do because we're running out of time, I don't like to make this video too long, could you have half a minute? Now, I guess that depends on how the company bills you. If they, some companies round to the nearest minute, some do per second billing. So that, how we graph it is actually going to depend on how the phone plans bill you. If it bills you to the nearest minute, then you would not be able to draw the solid line. You would just do what we did before and just shade in the nearest numbers. But if they bill you per second, that means you can have half a minute, a third of a minute, that kind of thing. So then you would draw the lines. Anyways, here's your skill testing questions. So solve, check, and graph this. And then here is a video game selling, buying question. Talk to you later. Goodbye.